In our earlier discussions, we extensively dealt with the topic corrupt and anti-social behaviors or anti-self with no escape. There actually we elucidated how people have shallow thinking and live life without the necessary thinking. Well, we will now take up this aspect and show how people do the same thing in scientific subjects and a subject like mathematics and mathematical science, subject like mathematics or even mathematical sciences. And in fact, such a shallow thinking is unnecessarily introducing vagueness, and the avoidable vagueness, if it is really avoided, how much people will be benefited, and how people should be a little more careful in thinking and not live with contradictions and so on. Now let us take up the introduction of our school algebra to youngsters. Now what we are speaking are of high value not only to the teachers but also to parents who may not get, whose children may not get teachers who clarify such concepts, and for whom the knowledge up to the 10th class is more than sufficient. So now let us consider, for example, I am in fact tempted to say that these things are actually discussed once. I recall with great pleasure with Bapu, Sri Bapu and Sri Venkatramana, who was then alive. And I happened to be at Chennai, University Guest House for a UGC meeting. And they came to know about me and called me up and said that they are writing some projects and would like to discuss with me. So then they picked me up and we went to their house, and then they explained the points which I am trying to, some of which I am trying to place before you. So I in fact consolidated then that you want, in Telugu of course, Gabra is confusion. And I said you want to remove Gabra from algebra. So now let us see how it goes. So let us take the very first concept of a constant which is introduced. Very many people say that it is a fixed quantity. Fixed quantity. See the usage, a little analysis of course clears up the vagueness about it. So fixed quantity suggests variable quantity, of course, which they are going to use later. And actually they will say that a variable is a variable quantity. Okay. Now, immediately the question comes in, what is fixed quantity? A fixed number. Okay. Variable quantities, where are they? Variable numbers, are there such things? So this is an unnecessary confusion that is being brought into the earlier stages of the subject of algebra. Okay. Actually, algebra is a study of is nothing but study of the real number system at the school level uh, through using an appropriate formal language to make the problems fairly simply stated and understood. Now, coming back to this constant, okay, give an example of a constant. Just ask that, this is the way we clarify. Say you will say 3 to cut the story short. Well, 3 is the name of a number. Just like Ramarao, Govindarao, Visakhapatnam, like that. Right? So, then it is simply a proper noun. So, if you want, you can simply say that a constant is nothing but a proper noun which is the name of a number. This is correctly the known to unknown principle that is followed in science. And things get, there is no need to get into any confusion, just to go step by step with clarity. So here the vagueness is gradually introduced like this. Can you say that Ramarao is a fixed person? It's not a fixed, it's a quantity of a fixed person. It's not like that, a particular person. So in a similar manner that there is the name of a particular number. Okay. And that type of proper noun. So now let us go to the variable. Saying variable quantity is too much. Okay. Then what is it actually? See, what you want to do is ordinary statements like you think of two numbers. When you add the first number to the second or the second number to the first, you get the same result. Now, you want, this is a general statement. If you don't want this general statement, you will say 5 plus 3 is equal to 3 plus 5, 10 plus 9 is equal to 9 plus 10. And you should keep on saying so many things. So instead of that, a general statement sweeps away all these, covers up all those statements, all such separate statements. So that is the purpose for which you use a common noun. Simply common noun, and common nouns are used. So the number is the common noun there. Okay. So that is so what he is trying to say is now as what is now called x plus y is equal to y plus x for any numbers x and y. That means he is trying to think of two numbers. Two are the same, doesn't matter, okay. Numbers, think of them. One I call x, one I call y. Only just temporarily. Instead of that, one could say a first number, second number, I thought, and so on. But so here the point is x, y, they are numbers. The first, I want to talk about a proposition involving two numbers, and then of course I conveniently gave an ad hoc names as x and y. So the x and y are there only common nouns, the number x, the number y. So number, that is the underlying common noun. So a variable is nothing but a common noun. Okay. And you want to talk about statements involving two common nouns? Well, you have to say, let us think of two persons, the first person, second person, or give names, like that, here x and y. Okay. So, after all, a variable is nothing but a common noun. It is like a common noun. Some people call it abstract noun. Doesn't matter, whatever it is. So, if this is clarified, you can have this clarification subsequently when somebody learns the computer science and all. So, there also they use the word variable and all that. So, there is no need to get any specific confusion or like that. Okay. And the x and y they are introduced, they get into the formal language. You can use without x and y the first number, the second number and so on. But you want to make use of, you want to say some statement which involves three numbers, it becomes all the more clumsy. So for example, I want to tell somebody how to multiply by 21. So you take a number, you multiply by 21 means you multiply by 20 and 1 and add. That is our algorithm actually. Okay. So there is the underlying law is x plus y into z is equal to xz plus yz for all numbers x, y, z. It's called the so-called distributive law. Okay. So the formal language, the nouns, the common nouns, the proper nouns, all these things are given specific convenient names, and it is nothing but an ordinary language and a suitable formal language to carry on the discussions more conveniently. Well, now let us take up other types of confusions, like, sir, plus into plus is plus. Okay. Then minus into minus. If it is better minus, why not minus? Why should be plus? This used to be and well, some of the teachers, what is all this plus into minus is minus. So they will simply say, all this simply means, see, if there is a plus sign before parenthesis and there is an expression, you just remove the parenthesis and keep quiet. If there is a minus sign, change all the signs after removing the parenthesis and then remove the parenthesis, okay? So this kind of thing is only trying to produce clerks and not really scientists. So actually the laws, and they are systematically applied term by term. Now come back to the question of minus into minus is equal to minus. What does it mean? What is it you are trying to say thereby? This should be a very sensible statement. What he is trying to say is that
minus is plus.
Minus into minus is plus. Yes, that is the statement, I'm sorry. That's what, okay. So, now what he is trying to say is that you take numbers x, y, minus x into minus y. What is it? It is nothing but plus xy. A plus you can omit, of course. It is nothing but xy. It is a matter of proof. It's a theorem, just like a theorem in geometry. And there is no question of opinion, or there is no question of discussing why not we take it this way or that way. So, starting from the basic laws, we prove such things in school algebra also. And the concept of theorems is not properly emphasized as it is so much emphasized in geometry. And people think that algebra can get away without any theorems or statements to be established and so on. So this confusion should be completely gone. Mathematics, every branch has got certain basic concepts, then some basic axioms, Then of course matters to be proved, and which the matters which are going to be repeatedly useful are called theorems, and so on. So this is how we clarify. Now let me talk about the common blunders committed in equations. Starts from equations at the school level, goes on to differential equations at the higher levels, okay, and other types of equations. So the same mistake. See, the common mistake that people commit, somebody says solve the equation and gives the equation. Immediately people proceed saying that therefore, as if something is given. But he does not correctly understand what is solving the equation. When he solves equations in the school and runs to equations of higher order types and so on and so forth, and the same types of mistakes they come in. You know what happens actually, because we have given details of these things in our web. Because normally I maybe it's a good idea to use a board, but you can open our web. We have very simply given the equation, therefore, x is equal to something. Yes. So, x is equal to so much. See, sometimes what happens is therefore, 0 is equal to 1. What does it mean? Has he proved that 0 is equal to 1? Certainly not. What he is doing is, an equation is given. He assumes x is a solution of the equation. That is a number which when substituted there satisfies the relation. Okay. That is what he is assuming. He must specifically, logically assert himself that he is assuming it. So when he assumes like that 0 is equal to 1, that means he gets a contradiction, an absurdity. Okay. So his conclusion is the equation does not have a solution. So and sometimes he assumes that there is a solution. Then you will get x is equal to 1. But actually when he plugs in 1 for x in the relation, is not satisfied. Then also he will have to report that if there is a solution, it is 1. But that 1 is not a solution of the equation. Therefore, the equation has no solution. So it is this type of clarity that is important, and we refer for such things to our somas.org, where we give details of these and also the cases with the differential equations. In differential equations, they do more things. In addition to repeating mistakes of that kind, they also, in fact, put some steps which most of the teachers themselves won't understand. This is what we are observing in our interviews with teacher selections. Okay. So, and they said dy by dx. Then separate out dy dx. They do not know what they are talking about. They produce from a differential equation, they write down therefore finally some ordinary equation. What exactly they got? Do they understand what is meant by solution? Now all these things are carefully detailed out in our web, and such mistakes are simply avoidable. Okay. And finally, I will tell you one of the biggest jokes of absurdities. There is a concept called Dirac Delta function. So I am not going to go into the details, but it is described to be a function with certain qualities. Let me not bother about those qualities. Actually, such a function doesn't exist. Excuse me. Such a function doesn't exist. But Dirac held that such a function exists. He he and so many people now in books of engineering, etc., use the Dirac Delta function to do a lot of mathematics. Interestingly, the results are correct. Well, most of the results, not all, are correct, but the function doesn't exist. So, what does this speak? So, in a very such a subject like mathematics, people are still not sufficiently careful, logical in their life. In an ordinary life, of course, that many people are illogical and insufficiently prepared for thinking and commit all sorts of mistakes are very well elucidated by us, right? So this particular Dirac Delta we will be, of course, detailing out in our web and in the process of our updating in a very short time.